Okay, so it says M is the midpoint of KL. So here is M right here. If M is a midpoint, then KM is the same length as ML, and that's what it's looking for. KM equals ML. Then definition of segment bisector. If something bisects something else, it's breaking it exactly in half. So BD bisects AC. So that means that AB is the same length as BC. So we can say that AB is congruent to BC. Then we have reflexive property, which we've been seeing a lot. I haven't always been saying it because I've been working on the concept more than the vocabulary. But reflexive property, when you have a shared side, JL equals JL. So this here, this is a shared side. And therefore, JL is congruent to itself, JL. Let's zoom in a little bit more. Okay, then it's focusing. Down here for angles, we're going to look at the reflexive property for angles. In this picture, you have two triangles. You have a triangle right here, and you have a triangle right here. So this is like your given. And with these two triangles, they share an angle, angle B. So in this pink triangle, we have angle B, and in the blue one, we have angle B as well. And in these two triangles, angle B equals angle B. Then you have right angles theorem. So all right angles are congruent. So given this situation, where you have two right triangles and right angles right here, you can say that angle G is equal to angle K. Or congruent to, however you want to say it. Then we have definition of angle bisector. It says that BD bisects ADC. So here is the angle bisector. And with that angle bisector, this side of the angle is the same measure as this side. So angle ADB is equal to angle BDC. And then vertical angle theorem, when I first introduced vertical angles, I said it comes up a lot. It's like very popular. Vertical angles are congruent. So in this situation, your vertical angles are right here. This angle is equal to this one. So angle NPL is equal to or congruent to angle MPO. Okay, so pretty simple so far. Then up here is where it all comes together in a pretty or not so pretty picture. Parallel lines and transversals. So in these pictures, there are parallel lines and transversals, and I'm going to point them out here. So right here, we have parallel lines right here. And while I'm highlighting parallel lines, we also have parallel lines right here in this parallelogram. And then we also have a transversal right here. And then in this case, right here. And with that whole situation, we have alternate interior angles that are congruent. So with the parallel lines and transversals, alternate interior angles are equal. So this angle and this angle, which are alternate interior angles, are equal. So angle TQU is equal to angle URS. And then you could potentially use that to prove that those triangles are congruent. or as part of a proof. And then over here, same situation, alternate interior angles are equal. So angle ABD is equal to BDC. Okay, and then corresponding angle theorem. Remember, corresponding angles look like this. So if you have parallel lines and a transversal, corresponding would be like this angle and this angle. So in this situation, it's hard to see what's going on, but it does have these little symbols for parallel lines. So this line is parallel to this one. And then this would then be a transversal. And then as far as corresponding angles go, this angle then corresponds with this one, and we can prove that those angles are equal. So angle VT or VSU is equal to angle WUT. Okay, and then down here, it's just a little bit more practice on like side, angle, side. I feel like you can't have enough practice with this because it just comes up a lot and it's easy to get right if you know what you're looking for. So number one, it has angle, side, angle, side. So that would be none. Number two, side angle, and then the shared side is equal to itself. So we have side angle side. Then 3 and 4, this is equal to itself. So side, side. And then number 4, this is equal to itself. But this gives us ASS, so none for this one. There is one situation where ASS works. One situation where ASS works to prove congruence, and it is with right triangles. Right triangles. So just make this little like note down here. So with right triangles, you have a right triangle here and a right triangle here. If you have a leg in common and a hypotenuse in common for a right triangle, you essentially have ASS, but we don't call it ASS, we call it hypotenuse leg. A hypotenuse in common and a leg in common. So if you get the ASS one, check to see if it's a right triangle, and if it is, then you can prove they're congruent by HL, hypotenuse leg. One of those little like caveats. Okay, so next, we already filled in this page. We're going to skip to the next one. So find this proof. Number 18, complete the proof. Okay, so we're doing the same thing. We're just bringing it into the proof format. So given, it fills in the two givens for us. Just looking at what it says that CE equals AC. Cool. ER right here equals AR. We're trying to prove that these triangles are congruent. Well, I have side, and then a shared side. So if I just prove that this side is equal to itself, then I have side. And that's exactly what it's looking for. So reflexive property is CR is congruent to itself, CR. And then we can prove that those triangles are congruent because of side. I'm going to add one more thing because sometimes they do add one more thing and I just want you to be aware of it. Sometimes once they prove that the triangles are congruent, they'll then ask you about like angle E equal to angle A. It might say, okay, now angle E is equal to angle A. And the reason why you can say that is because of CPCTC, corresponding parts of congruent triangles are congruent. So you can see why it has an abbreviation, CPCTC. What it means is once your triangles are congruent, then you can prove that all the remaining parts are congruent if you need to. So if you've already proved your triangle is congruent and it has like one more step where it says something's equal, it's usually this reason. Because once your triangles are congruent, then all the parts are equal. Okay, next one. Complete this proof. It says R is the midpoint of AG, so that means that this is equal to this, and R is the midpoint of ET, so that means this is equal to this. Okay, I can see where they're going with this. It says definition of midpoint, well I can say that GR is congruent to RA, because R is that midpoint. And second one says definition of midpoint again, so TR is congruent to RE, definition of midpoint. So I'm trying to prove that these are congruent. What else do I have? Well, I have vertical angles, so I can say that these two angles are equal, and that's exactly where they went with this. The reason would be vertical angle theorem. And then you can prove that those triangles are congruent because of side angle side, side angle side. Okay, next. Ooh, they're having us fill things in. But honestly, this is no more complicated than this because a lot of what they filled in was like given in the proof statement. So we're going to start there too. So that way we only have a few things to fill in after that. So starting out with given, first reason given, BAB congruent to BC. And I'm going to do a second line for given, AD congruent to CD. We're not going to use this last line. And then our proof statement goes in the last part here. Okay. You guys caught up? You keeping up with me? I feel like I'm going fast today. You guys are awesome. Okay, so AB equals BC. As we can see, this equals this as is given. Last thing we need to prove is that this is equal to itself. So we can say that BD is congruent to BD, reflexive property. And then we have side, side, side. Okay, and next. Okay, so here again, starting out with the given, AB is congruent to BC. And then I'm going to actually just use a second line for the given. It says BD is the angle bisector of ABC. BD is angle bisector of angle ABC. And the last statement, I'm going to put in the proof statement just to get that blank right as well. Okay, so it says AB is equal to BC. They already labeled that. Cool. It says BD is the angle bisector of ABC, so that means this side of the angle is equal to this. So in my reasons, I can say that angle 1 is equal to angle 2 because of definition of angle bisector. And so I have side angle, and because of the reflexive property, I can prove that this is equal to itself. So BD is congruent to BD, reflexive property. And then last but not least, side angle side, side angle side. So I can say that these are equal because of side angle side congruence postulate. That's it. So your homework is on Schoology. It's some proof practice like this. If you have any questions, let me know. If you finish it early, then get Alex started for the week. But otherwise, you should be good to go. Good job today.